Hey guys, welcome to my channel. My name is Lokesh. I work as a data architect. So we will continue our book reading series where we are reading the book called AI Engineering. And one thing to be called out here is that we are only covering chapter 10 of this book. So if you are new to this channel, consider subscribing. And if you are already following this channel, make sure that you read uh, the previous chapters that we parts of the chapters that we have read. We have created a playlist specially for you so that you can go through all of the reading in a single go. So the idea here is that we are learning together. In every video, try to emphasize the fact that AI and Gen AI is relatively new technology as far as the general public is concerned. Only the PhDs or the experts who have been working in this field know how this technology has evaluated for people who come from different backgrounds like data engineering, front-end development, or non-IT. So this is something that has come as a new technology and that has taken the world by storm. So again, I would like to say that if you want to make a transition, AI engineering would be the best domain within Gen AI where you can make the transition. So we'll continue studying more on this in the coming videos in this video and more tech topics where I think I need improving so that I share with you the learnings that I've got and also maybe as we are doing today share or study with you guys. So if you look at the architecture, so in AI engineering we are covering the chapter 10 of this book which specifically talks about how to build an Gen AI architecture. So there are different components around it. So in the last video we covered the types of cache. There are two types of cache: exact cache or semantic caching. I think in exact cache it's whatever query you type, the system looks up for that particular query, even if it's slight deviation, from the semantics or maybe from the spellings of the query that you're typing. It will not give you the result, even if you have, typed, or if even if you've typed when the user has already used that query in the past. So that is something you need to keep in mind. And the other one is semantic caching, where uh, the lookup will be done based on the semantics of the query that you have written. So if the earlier query had a semantic score of let's say X, and if the new query has a semantic say let's Y, and if you define a threshold that if the new query has semantic score maybe in a proximity of 80% of X, and if Y is 80%, if Y is greater than or equal to 80%, then Y will qualify as the query that has been asked before, and that is where it will try to get the results from the cached place. So this cached place could be your RDBMS, or could be your in-memory storage. It could be anything. And there are so the other things is that you need to make sure that your cached location doesn't get overpopulated or doesn't get completely full. For that, you have different eviction policies. You have first in, first out, uh, least used one, evicts first. So there are different, policies around it. So it's not that whatever cache system that you're defining will grow forever because there is, some space associated with that. And then we'll also looked into uh, the queries which should be cached so that all the users can get benefit out of it, or some of the queries will have the PII data, for example your account number, your maybe if you're in India your PAN card, or your bank account number. So those things shouldn't be cached, otherwise the other users can get access to that, and that would be a very uh, very high breach in the protocol. So that is something that we have to keep in mind. So we'll continue now. On the last cache, in the last video, we covered about the cache. So this is how our architecture looks like for now. So let's do the book reading. So add agent patterns. So step 5 is now we are adding the agent patterns. Uh, Agentic AI is a buzzword, is the latest trend in Gen AI. So it would be interesting to know what is covered in this. The application discussed so far are still fairly simple. Each query follows a subsequent sequential flow. However, as discussed in an application flow can be more complex with loops, parallel execution, and unconditional branching. Agentic patterns discussed in chapter 6 can help you build complex applications. For example, after the system generates an output, it might determine that it hasn't accomplished the task and that it needs to perform another retrieval to get more information. The original response, together with the newly retrieved context, is passed into the same model or a different one. This creates a loop as shown in figure. So I think the agents would come into picture when you are just not just doing uh, a simple prompt and expecting an answer. If you want to maybe achieve a particular output by following multiple steps, then I think you would need agent intervention. So as you can see here, you got the response from the first step, then the response feeds into the system again, and it will try to do a subsequent step. The yellow arrow allows the generated response to be fed back into the system, allowing more complex application patterns. A model's output also can be used to invoke write actions such as composing an email, placing an order, or initializing a bank transfer. Write actions allows the system to make changes to its environment directly. As discussed in Chapter 6, write actions can make a system vastly more capable but also expose it to significantly more risks. Giving a model access to write actions might be done with the utmost care. With added actions, the architecture looks like 10-10. So this is a continuation with what we discussed, that if you want to perform a particular group of tasks, or if you have some output in mind, that okay, I will follow these tasks and this would be the output. For example, if you want to write an email, if you want to search online and write an email, or you want to plan your holidays. So first of all, you need to see what are the best places you want to go, and then try to find out what could be the discount that you can get, what could be the time period in which you can visit, and then at the very end, you would want to book tickets, book flight tickets. So everything that doesn't require research and where it requires some actions, that is where your agentic system comes into picture. So I think for maybe tasks like if you're writing an email to your friend, that is well and good. But what if you're using this for your boss, or maybe in a corporate environment? In that case, you have to be absolutely sure that the email that is being sent is ethical, and whether it covers everything or not. So that is where you have to be very very careful, not to exactly automate everything, but to have some sort of human intervention as well in between. If you followed all the steps so far, your architecture has likely grown quite complex. While complex systems can solve more tasks, they also introduce more failure modes. That's true, making them harder to debug due to many potential points of failure. The next section will cover the best practices for improving system observability, monitoring, and observability. Let me see how long this chapter is, whether we want to read it in this one or not. Yeah, this looks like a lengthy section, but let's maybe look at the introduction. So now this is how the final architecture looks like. Uh, you have various components. You have context generation, you have guardrails, you have routing, gateways, scoring, and then you're able to write actions as well. And then you are able to, take the output and put it again into the construction, context construction, maybe to call the same LLM or maybe, to call a different LLM. And then obviously you'll have the right actions and not to forget about the caching part as well. So this is how it looks like. Now let's read about monitoring and observability. Even though I put observability in its own section, observability should be integral to design of a product rather than an afterthought. The more complex a product, the more crucial observability is. Observability is a universal practice across all software engineering disciplines. It's a big industry with established best practices in many read-to-use, proprietary, and open source solutions. To avoid reinventing the wheel, I'll focus on what's unique to application builds on top of foundational. That's the book's GitHub repository contains sources for those who want to learn more about observability. The goal of monitoring is the same as the goal of evaluation. So, although observability and monitoring might sound similar in literal terms, but I think they have a different meaning when it comes to Gen AI and AI applications. Or maybe it is something that has been there for all the applications, for front end applications. But to be honest, whenever we use monitoring, I would assume that observability would be part of it. So let's try to Gemini what is the difference between observability and monitoring in Gen AI applications. So let's see, what it gives. Two distinct roles. I think we're looking for a table. So monitoring is like checking the vital signs of a patient to ensure they're stable, conducting a thorough examination. Also, they're giving it an analogy from the real world. Medical device system is interest rate, tracking predefined metrics and logs to identify issues or deviations from expected behavior. Yeah, I think let's come back to this. I think here also, if you look at it, there is no clear difference that stands out.